It's closure time. Here we go. These are closure syntax expressions. So we're going to play with closures a little bit. In this demo, first of all, we're going to use the array method .map, which executes a given closure over all values in the array. So the signature for this map method is it takes a transform. It's a named closure, if you will. And the closure is it takes a type and it returns a type. That's what that means. So when you see these kinds of things in the tooltips, this is what you're going to see, and then you're going to want to replace this with your actual type of the closure. So here we have an integer array, 1, 2, 3, 4, simple 4-element integer array. So now here, how do we call the map function? Well, let's let times2 equal ints.map, and then all it does is take a closure. So the closure we're going to give it is a as an int, mapping to or returning an int, and that is the type of the closure, and then in, and then return a times 2. So that should work. So if we print out ints and then times 2, we get ints of 1, 2, 3, 4 times 2, 2, 4, 6, 8. That makes perfect sense. All right, so now let's use what we know about closure syntax to simplify this closure expression a bit. Since the types are inferred from the context, we can omit the type from the closure's parameter list. So here we have let times3 equal ints map a, not as an int because that type is inferred, a returning an int in return a times 3. So that simplifies it as a first step. And of course, if we print that out, ints times 3, we get 1, 2, 3, 4 times 3 is 3, 6, 9, 12, which it should be. So that much is good. Now, the same is true for the return type, so we can drop it and the arrow. Because if we don't need a return type, we don't need an arrow. So just like in a function. So let times4 equals ints.map a, without a type, we already know the type, it's inferred, in a times 4. That works. If we print that out, we see ints 1, 2, 3, 4 times 4, 4, 8, 12, and 16. So it's all working and it's all good. We can also use positionally named parameters. Here we go. Let times5 equals ints.map. Well, we know where a is. It's the first parameter. So we can use $0 times 5. And if we print that out, we get ints r times 5 r. Let 1, 2, 3, 4 times 5, 5, 10, 15, 20. Everything is good. So now this shows you how to declare or define a closure that you're going to pass into a function. In this case, the mapping function. There's also a sorting function that takes a closure that gives you back whether A is greater than or less than B for any two consecutive numbers in the array or consecutive indices in the array. There's all kinds of functions in Swift that accept closures as parameters. So this is how we do it. All right, let's define our own function that takes a closure as a parameter. The idea here is when the discussion we talked about smallest int, now I'm going to give you biggest int. Here's biggest int, an array of ints. The biggest, the closure is given a name so that we can refer to it inside the function. Biggest, it takes two ints, it returns a bool, and then the biggest int method or biggest int function returns, of course, the int that we're interested in getting. So here's our retval, return value. For I equals 0, I is less than ints count minus 1, I plus plus. We discussed this. We don't want to overrun the indices of the array when we say I plus 1. So if we have 4 ints in the array, we only want to count up to 3 so that we can go I plus 1. The return value, if biggest gives us back a true, the return value is that element. Otherwise, it's that element plus 1. And we do that for each element in the array, comparing 0, 1, and 2, and 3, and 4, up until we get to n minus 1, because at n minus 1, we're going to compare it within. And then we return that final int. So what have we done here? We have said that this function expects to get a closure that takes two ints and returns a bool. But very importantly, it doesn't say how to do it. When do we tell it how to do it? Here. We've defined a bunch of ints, an array, 6 integers, where we obviously have a biggest value, and it's not the first or the last, so it should jump out. Use this function to find the biggest int in an array. Now we can use the full syntax, and we're going to go through all of these syntax statements just as we did with the max function. Let h equals the biggest int of a bunch of ints, given a an int, b an int, returning a bool, in if a greater than b, return true, otherwise return false. So let's go ahead and run it to check. We'll skip some of this. I've already tested, but let's check it with that h function and see if it works. So now it's saying the biggest int in a bunch of ints is 264, what we expected to see. All right, so now let's look at the I function, or the I let. I is equal to biggest int of a bunch of ints, and now we can get rid of these parameters. And we can also get rid of bool, or the return type. So we get rid of the fact that these are both integers, they're inferred to be integers, and we don't have to have the return type because it's inferred to be bool, in return a greater than b. A greater than b just says if a greater than b, else b greater than a. So otherwise, if a greater than b, this is the bool that we want to return. And of course, that one's going to work too. Let's try it. We should always test things before we say they're going to work. And it says the biggest int in a bunch of ints is 264. Okay, that's a neat way to do it. However, here's an even shorter with the positionally named parameters. So let j equals biggest int with a bunch of ints, buck0 greater than buck1. We've seen that in the discussion. We know it works, but let's test it anyway. These are positional parameters, and if we know the position and the types of the parameters, we can use these. So the biggest int in a bunch of ints is 264. Okay. With the greater than operator function, we know that greater than is defined over ints. It's a good comparison operator for integers. We can get even shorter. Classes and structures now, I haven't talked about this yet, but we will when we talk about classes, blah. But we will when we talk about classes and structures and other things. These can define functions that overload operators. And we'll talk about that in the next unit, of course. These are called operator functions. But we've already got a known operator over integer that returns the greater of two integers. So here it is. Or returns true or false depending on which integer is greater. So let k equal biggest int out of a bunch of ints, use the greater than operator, and that's it. So let's go ahead and check that, and that'll be our last experiment. And we already know it works. The biggest int in a bunch of ints is 264. Thank you very much.